Hey, hello, and welcome to Show and Tell. It's me, JP Sans Mustache, and I am back and excited to bring on some people here who've got some cool stuff to show. If you're interested in joining the Show and Tell, you can head over to the blog over at Adafruit. You'll see a little link there. Or jump over into our Discord. I have it on a monitor right there. That's why I'm pointing. And you'll find a link there as well for StreamYard. You just want to use a browser that'll let you share your camera and mic and maybe a screen share if you want to add that sort of thing in. And let us know what you're working on. Tell us what's happening. We have a few Adafruit people and at least one community person to show their stuff. First off today, I've got Erin. Hey, Erin. How's it going?
Good. I have a pretty cool project that I've been working on this week. It is a dragon.
Ooh.
Here he is. So this is a dragon kite toy. It comes with a like a rope for pulling it.
Oh,
and
cool.
then this one has a 6-meter tail. I don't know if you can kind of see it. Goes all the way back there. And what I did was added some Pebble pixel lights to it.
Cool.
This is actually 15 meters of Pebble pixels, and that we saw that whole strand there on the shop. And then inside the head, I have put some electronics. I've got a little mini sparkle motion in there and an on-off switch and a little USB battery that powers.
Oh, nice.
So this guy is running WLED. Those are my favorite. And so I can actually control them with my phone. And it's also got sound reactive effects on it, which is really cool. So I can, I don't know if this is going to be visible or not, but hello, like it will animate my voice, which I thought was actually going to be cooler than it turns out to be, because maybe I could tweak settings, but like when I'm spinning it, the wind noise and the ripple of the tail like just makes it, sets it off. So it's pretty cool. I actually made really these guys. I'm using segments in WLED, so all the lights inside of the head, the rest of the strand just ended up in there, and I sort of glued them all around. And I stuffed a whole bunch inside the eyes. So with WLED and segments, I can make the eyes one color, make all the ones in the mouth a different color, and then run a mirrored animation on the tail. So the left and right sides are mirroring each other, and that was super easy to do with just a couple clicks.
That's great. And for people who aren't familiar with the segments, can you describe what that is?
Yeah, so it's this is just one LED strip. It's attached to one pin. Super easy solder job. But I can say, hey, LED number 1 through LED number 74, let's make those this. And then LED number 75 through 79 can be something else. So you can actually segment out different parts of the LED strip without having to cut it. And control them each individually. And now with WLED 16, which just came out, the new version, you can actually layer effects. So I put, all the LEDs in the head are one segment, and then the eyes are a small segment within that segment. I can now layer a color on the bottom, and then on a different segment on the same LEDs, I can run an animation, a chase or a blink or something like that. So that's a really cool thing that the new WLED has is the ability to layer effects on the same few LEDs, which is...
That sounds great. You've convinced me to check it out. I haven't looked at the new WLED yet, but that sounds like...
You can also upload your own images and animated GIFs and that kind of thing. If you have a matrix, like there's a lot of cool stuff. I'm working on a guide where I'm going to kind of go into some of the new features and show what's possible.
Oh, that's terrific.
But let's finish the guide for this. It should be through moderation this week, and take a look for it. There's some pretty epic shots. I made 2 of them and went up to the mountains and did some spinning. They look amazing when they're flying.
So you're doing poi stuff with these enormous dragons, yeah?
It was not easy. I got the 6-meter ones, which I was just like, I'm a poi spinner. I've been spinning poi for 20 years. I could do this. I still tripping on them. Like they're really challenging. I'm gonna need some practice in order to really make these things work. I recommend, if you're not a 25-year veteran poi spinner, maybe start with shorter ones.
I'll look for the mini dragons.
The ones look epic. I had to climb up on top of a rock in order to get some of the shots, because like they hit the ground and then they tangle. If I'm on the rock, they can like swing past ground level, which was
amazing. Okay, I'm really looking forward to seeing the video and photos for the guide too.
Yay.
Very cool. Thanks so much, Erin.
Thank you.
All right, take care. Oh, very cool. I want some dragons. Okay, next up, we've got Scott. At least we've got Scott's name
Hello.
and some electronics. Hey, yeah, that's
You
this
can
is the
hear
new
me.
Scott. Hey,
That's
yes,
good.
I hear you.
Yeah, I don't know how to do two cameras at the
No
same time.
worries.
So what do I have here?
Yeah.
I have a couple new boards. One, I made myself a swirly grid that's really long.
Oh, nice.
It's a 5x22, and you're like,
Mm-hmm.
why did you do 5x22? Well, I had these IKEA Calyx bookshelves
Mm-hmm.
and they're great for. I have these custom sized cardboard boxes I store stuff in, and I'm going to use those to store the hardware and the loop testers. So.
Wow.
I can put these on the grid. I put the mounting holes on the grid for the swirly grid, and you can see I actually did two here, two next to each other. So they'll be connected over power over USB and then Ethernet, and you could put boards. Here's one board. This other one doesn't have a board.
Mm-hmm.
But the idea is that it's like an automated hardware test platform. So it has these two USBs go here, and then go back to the P4, and then the P4 makes them available over Ethernet. And the blinking here is actually just testing the I/O expander
Mm-hmm.
that we have to control some of the control pins for that.
Right.
And the other green light here is showing that the USB power is on, so that's a switchable thing as well.
Mm-hmm.
So most of it's working. Although I had lunch with a friend and they were like, "Well, if that's the way you did this, doesn't that mean that like this thing will happen?" And I was like, "Oh, you're right." So I do have some modifications to do this. I have a bunch of resistors to take off.
Okay. Yeah.
I was trying to allow us to do I2C testing by being able to pull up all the pins at once, but
Mm-hmm.
my friend pointed out that if you don't pull them all up, they're still all connected via resistors.
Okay. Yep.
Darn it.
So it's a big I2C party then.
Yeah, so everybody's connected over I2C pull-ups to everybody else, regardless of whether
That's
you're pulling up.
I2C conference call.
Yeah, when you're not pulling up.
Okay.
So I got to sort that out. But generally, I'm really happy because like the Ethernet works, the USB works.
Yeah.
I just made that mistake with the resistors, and I think I'll get.
One of the things you'll be able to.
Out. Yeah.
One of the things you in building the big grid, you said you'd be able to do maybe 4 or 5 of these up and test like 5 totally different boards at a time.
That's right.
Into them.
That's right. Yep. Yeah. So in particular, as Espressif comes out with more variants, so this is like a C5, and then I need a C61 and a Pi Pico, and like not every board, but every like microcontroller chip, right? Mm-hmm. Ideally, I would have set up so that it was like always it was on. I'd have access to it, and either me or like a automated testing for continuous deployment, or somebody files a bug for a C5 and we say, okay, Claude or LLM, like, okay, Clanker, try to fix it for me, and here's how you can have some like hardware to actually run the test with.
Yeah, right.
So yeah, just starting to work on this. Well, now I have the hardware and I have no excuse to get the software going to be able to actually do that. I actually have 10 of these.
Okay.
Because it's like most of the cost with that low volume is set up, and I was like, I could really use 10. So I actually have 10 that I think I need to take those resistors off. Although I also thought about maybe just always having pull-up resistors would be okay too. Just on every pin, and see how far I can get with that as well.
Good. Well, good luck.
So yeah, I'm working on that, and pretty happy that that's been the biggest mistake so far.
Yeah, good. All right. Well, good luck with continued testing. Thanks, Scott.
Yep. Thank you.
Take care. All right. Next up, we've got. By the way, if you're not over on the Discord chat, Erin posted a really cool photo of the Dragon Poi in action. So head over to the Discord if you want a sneak preview of that. And next up, we've got Maker Melissa. Hey, Melissa.
Hi. So I was working on adding a masking feature to the bitmap tools alpha blend function for CircuitPython. And I came up with a little demo here that, let's see if I can get it closer here.
Oh, nice.
And you can see it's actually using the alpha blending and showing the background through it.
Yep.
But it also makes it so the edges of the foreground image are anti-aliased.
Uh-huh.
So it grabs a nice, good copy of it. And I think this could be really useful for things like anti-alias fonts and stuff like that.
Yeah. Oh, that's super useful. So you're anti-aliasing that matte of the rook on the fly. So it's on each frame, it's picking different colors to match what's behind.
Yep.
Amazing. That's really impressive that that's happening. What board is that running on right now?
That's the Qualia with CircuitPython.
Yeah. Really cool. Will you show that again? Because I think
yeah,
that deserves another look. Let me make that full screen.
Let me see if I can get it to focus here. Oh, there we go.
There we go. So for the setup on this, is this like a couple of BMP files and
yes,
a separate alpha?
Yes, a mask image is just grayscale.
Yeah, really cool. And is there anything available yet if people want to check this out, or is that part of the Mac tools?
This thing, but I'll have to see if I can upload it somewhere.
Yeah, very cool. Well, thanks for sharing that. That looks amazing. Really impressed. It's so fast. Thanks, Melissa.
Thanks.
All right, and next up from the community, we've got Todbot.
Hey.
Hey, Todd.
Good to see you, man.
Good to see you. How's things?
Pretty good. So I do a lot of USB development. Like, I mean, pretty much all the Adafruit boards have USB on them, and so there's a lot of complexity to USB. And there on the Mac, there's been this really great program called USB Prober that shipped with the developer tools like 15 years ago or something, and it was last updated maybe to like 10 years ago. And so it's an Intel only app, and they just announced with like the next version of Mac OS they're not going to support the Intel Rosetta emulation that they got going. So like all your old apps won't work anymore. So for the last couple of weeks, I'm like, I know, I'm going to recreate the USB Prober app using Tori, which is this great sort of cross-platform way of doing apps. So if you could share my screen, this is basically what USB Prober looks like, but this app runs on Mac, Windows, and Linux. And I'm mostly focusing on Mac because it's what I use for a lot of this stuff. But so USB is really interesting. Your little USB devices, each one sends a bunch of different little chunks of data, and I'll show you one here. I'll show you this is a PicoW running CircuitPython. So the first thing it sends is the device descriptor, which is where it gets like the name of the device, like the name of the company who makes it, and like the vendor ID and product ID, which you might have heard of. And that's one little chunk of data. The other little chunk of data is called the configuration descriptor. And that's where you'll get things like how much power does this USB device need, which is like sometimes if you plug in something that doesn't work, it's because this configuration descriptor says, hey, I need 500 or 1.6 amps or whatever, and your tablet says no. But it also says these are the various interfaces, basically the different sort of data channels that this USB device supports. And you see the CircuitPython supports a lot. Like by default, you get USB serial, which is what the CDC stuff is. You get thumb drive, which is the mass storage. You get HID, which is keyboard and mouse. You get audio, which is actually part of MIDI. So like these two things, kind of like the way CDC needs two interfaces, MIDI, the MIDI interface needs these two interfaces. But then inside of the HID interface, you can go inside of this and you can look at the HID report descriptor, and you can see, oh, these are the different types of data packets as a HID device that it can send and receive. And so in this case, it's receiving things as a keyboard, as a mouse, and this is for the consumer buttons for like the play, pause, brightness, things like that. And so this is what USB Prober does, and my USB Probster app almost does everything that it does. It's still early in the days, but you can go download it. I'll post a link in the Discord. But I'm really happy that I've gotten this far. Claude helped a bunch for the parsing of all this data, because one of the other problems with Mac Tahoe OS 26 is that a lot of the tools we used to use to get this information on the command line has gone away because they've changed all the information. And so in addition, I'm shipping a command line tool that basically works like LSUSB on Linux. So we'll be able to have that functionality. But yeah, so this is my current sort of passion for the next couple of weeks.
That's great. USB Probester. I'm excited about that.
And like, so as you plug in different devices, it'll automatically refresh. So I just plugged in an Itsy Bitsy that's running Arduino Sketch.
Yeah.
And you can see in this one, I've got it set up that that is a MIDI device. So it's always got the serial monitor sort of like serial thing that Arduino has, but then I've added the ability to do MIDI. And so this is kind of what a Arduino sketch looks like that runs MIDI, and then this is what a CircuitPython sketch looks like that runs MIDI. And so it's really handy to be able to debug, like, oh, did I turn MIDI on? It's like, well, the computer doesn't think that you turn MIDI on if it doesn't show up here, you know?
So for example, if you go into a what is it, the boot pie, and say, I don't want this endpoint, you'd be able to verify that sort of thing on here.
Yeah, we can put this Pico in boot mode right now, and you mean in boot.py, exactly. Yeah,
right.
Yeah,
where you can say this does do MIDI, but it doesn't do mass storage, or those are going to be reflected here as a way to double check those things, right?
Exactly, yeah, because you have to do that on ESP32 S3 devices because they don't have enough USB endpoints to support doing both HID and MIDI and all the other stuff that CircuitPython does.
Yeah.
But like one of the things I use also this for is, like, is my board actually in bootloader mode? And so here I just put the Pico in bootloader mode. You can see it shows up different. It's called RP2 boot.
Yeah.
And you can see that it only supports this this vendor specific interfaces, which is what Pico tool uses. If you ever use the Pico tool command line tool. And then it shows up as the UF2 mass storage device. And so, yeah, this is like super handy, and it's mostly correct. I'd say it's like probably 90% correct. There's still some things I'm working on, but yeah, it's parsing all these different data packets that are stored in your USB devices and that are sent to the computer when you plug them in.
It's so much. Like
it's so much.
I've been doing some stuff with BLE scanning, and just the sheer number of different things of like a device that's just advertising BLE reminds me of this. It's like, got a lot to say about.
It's amazing how complicated these are. And so one of the things that that you can do is you can save this information out as just text files, which is what the original Mac Prober could do. And that was really handy to sort of like, when you're trying to figure out how a USB gizmo works, is you save all this information out and you kind of walk through it, and you can walk through the exact bytes of the configuration descriptor. You can walk through the exact bytes of the device descriptor. So you can see if you're trying to kind of clone a device, you know, and I want to make a CircuitPython thing that acts just like a the
game controller,
those cool old scroll wheels or something from Griffin, you know, the PowerMate, was that what they call it?
Yeah. I'm still looking for my box of them. I have 3 of them here somewhere. Since someone just published a new driver for it, I may dig those out. But then, if you basically export that text or JSON, looks like you've added, you could then use that in cloning it.
Yep.
Really cool.
That's my
hide hubs. That's handy too.
Yeah, because like turns out there's a lot of hubs in your USB setup, because like your monitor will have one, your computer will have 2 or 3, and so they're all USB devices. So let's just hide them.
Yeah. What's Razer Kaio? Is that a crazy mouse or something?
No, that's a camera. It's not. I'm not using it right now, but this is what a camera looks like. It's got for some reason 3 different interfaces for video, and then it's got a couple of channels for audio, and then it's got this interface association, which I think is kind of how the different things map to different other things. I know how to parse this. I don't know what it means exactly, because it only really applies to AV devices as far as I can tell.
Fascinating. Well, thank you for your work in keeping this dream alive now that Apple's done with it, because it hasn't ceased to be useful. So thanks so much, Todd.
Yeah, and if anybody wants to try this, please let me know if you get any weird results, and send me the output so I can try to figure out like how to fix it. Because I want to make this work for the next 15 years that I use this tool.
Fantastic. Thanks so much, Todd.
Thanks, man.
All right, take care. All right, and that is going to do it for Show and Tell for tonight. Thanks everyone so much for stopping by. Thanks to everyone for showing your projects. Remember, anytime you want to come on, just take a look at our blog, take a look at the Discord in the live broadcast chat channel. We've got info there. It just takes a browser and some permissions, and you can join up. I will be on the workshop in the workshop right here tomorrow for my show, 1 o'clock Pacific, 4 o'clock Eastern time. So come on by to check out what I'm working on. And then after that, I believe we're going to have some Foamy Guy deep dives for the next few weeks. I think on Fridays, Scott is going to be out. So I believe if I have that correct, that we'll get some Friday deep dives with Foamy Guy. I could be wrong. He usually also does a Tuesday morning, so I'm not sure if he's doubling up. And then we'll be back following week with another product pick of the week and our 3D Hangouts on Wednesday, show and tell. So thanks everyone so much for stopping by. This has been Show and Tell for Adafruit Industries. I'm John Park, and I will see you tomorrow. Bye-bye.